You typed something into ChatGPT this week. Maybe you asked it to write an email, or explain something you didn't understand, or help you think through a problem at 2 in the morning. And in that moment, you probably didn't think about what happened next, because the experience feels effortless, instant, almost weightless. It lives in the cloud, right? That's what we tell ourselves. The cloud. That soft, invisible space somewhere above us, where the internet just works. Here's what the cloud actually is. Concrete. Steel. Tens of thousands of servers stacked floor to ceiling. Cooling systems the size of aircraft hangars. And more electricity than some small cities consume in a day. Running, without pause, every hour you're awake, and every hour you're asleep. That feeling of weightlessness, it has a physical address. And lately, that address has been getting a lot more expensive. Here's something most people don't realize about artificial intelligence. When you use a traditional search engine, type in a question, get 10 blue links, that process is relatively lightweight. A small flicker of computing power, and it's done. AI is different. Every time a large language model generates a response, it runs a calculation across billions of parameters. Not once, not twice, thousands of times per second, across millions of simultaneous users. The computing demands of modern AI workloads are substantially greater than anything the internet was originally built to handle. Intelligence, it turns out, is hungry, and someone has to feed it. The companies that built AI didn't just build software, they built an industry, a physical industry, of land, of infrastructure, of power lines and cooling towers, and enormous buildings that hum through the night. And right now, that industry is growing faster than the grid that powers it. Think about the companies you associate with artificial intelligence. Microsoft, Google, Amazon, Meta, OpenAI, and on the frontier, Elon Musk's xAI. For most of the last decade, they competed in software. Better models, faster chips, smarter algorithms. That competition hasn't stopped. But something else has started alongside it. Something most people aren't watching. They are now competing for electricity. Not metaphorically, literally. These companies are signing long-term power agreements, negotiating directly with utilities, funding energy infrastructure, and in some cases, exploring energy sources that were considered fringe just a few years ago. Consider what Microsoft did in 2023. The company announced an agreement connected to restarting Unit 1 of 3 Mile Island, the Pennsylvania nuclear plant, most famous for being the site of America's most serious commercial nuclear accident back in 1979. The undamaged reactor had been shut down in 2019, largely for economic reasons. Microsoft's energy needs helped make the case for bringing it back online. A technology company, restarting a nuclear power plant. That sentence would have sounded strange 5 years ago. But it makes complete sense once you understand the scale of what AI requires. And Microsoft isn't alone. Across the industry, there is growing interest in what are called small modular reactors. Smaller, theoretically faster-to-build nuclear plants that could be sited closer to the data centers that need the power. These are still largely in the development and early planning phase. They are not yet a widespread reality, but the investment and attention flowing toward them from some of the world's most valuable companies tells you something important about where the industry believes it is headed. This is not a software race anymore. It is an infrastructure race, and the resource at the center of it isn't code, it's kilowatts. The electrical grid in the United States was not designed for this moment. Much of its core infrastructure was built decades ago, in an era when nobody imagined that a single campus of server buildings might draw as much power as a medium-sized town. Upgrading that grid takes time. It involves permits, regulations, construction, and coordination across utilities, municipalities, and federal agencies. It does not move at the speed of software. And that mismatch between how fast AI is growing and how slowly physical infrastructure can be built is one of the defining tensions of this moment. The companies that can solve that tension first will hold an advantage that goes far beyond their models. Let's come down from the scale of nations and corporations. Let's talk about a neighborhood. In communities across Virginia, Texas, Arizona, and the Midwest, hyperscale data centers have been appearing, sometimes quickly, sometimes quietly. These are enormous buildings. Some of them cover more ground than multiple city blocks. And they don't just exist. They hum. The cooling systems that keep servers from overheating run continuously. Some residents near large data center campuses have described a persistent low-frequency sound, not loud enough to be a noise complaint in every case, but present, constant. The kind of sound that becomes the background of your life. That's not nothing. That's someone's front porch. Water is another part of the story. Many data centers use water-based cooling to manage heat. The volumes involved can be significant, particularly in regions where water is already a sensitive resource. In areas facing drought conditions, that conversation has become complicated. There are also genuine economic arguments on the other side. Data centers bring construction jobs. They generate property tax revenue. They can revitalize areas that lost industrial employers years ago. In some communities, they are welcomed, not reluctantly, but genuinely, because they represent investment in places that felt forgotten. This is not a simple story. Most honest stories aren't. What's true is that the infrastructure of artificial intelligence is landing somewhere. It is landing in specific places, on specific streets, near specific homes. And the people who live there, who never voted on what AI should cost, or who should bear that cost, are experiencing consequences they were not asked about. That is worth sitting with. Every technology has externalities. The question is always who absorbs them. And in the age of AI, that question is being answered right now, in zoning meetings and utility hearings and community discussions in towns whose names you may never have heard. Now zoom out, as far as you can. What you're looking at isn't just an energy problem, it is a geopolitical one. For most of modern history, national power was measured in armies, then in oil, then in financial systems. At different moments in history, the nation that controlled the most critical resource held a structural advantage. We may be entering a new version of that story. Artificial intelligence requires three things at scale: computing power, data, and electricity. The first depends on semiconductors, the advanced chips that make modern AI possible, the majority of which are currently manufactured in a handful of facilities concentrated in Taiwan and South Korea. The second is a question of information access and regulation. The third is physics. You cannot fake electricity. The United States, China, the European Union, and others understand this. The investments being made in AI infrastructure are not purely commercial decisions, they are strategic ones. China has been expanding its data center capacity aggressively. The European Union has been navigating the tension between AI ambition and its stricter energy and privacy regulations. The United States is attempting to modernize a grid that was not built for this century, while simultaneously trying to maintain its lead in frontier AI development. None of these are simple problems. All of them are connected. Semiconductor policy, energy policy, and AI policy are no longer separate conversations. They are the same conversation. And the countries that understand that earliest, that treat electricity and chips and infrastructure as strategic assets rather than background utilities, will be better positioned for what comes next. Nuclear energy, in this context, stops being a debate about the past and starts being a debate about the future. Renewable energy, wind, solar, is growing rapidly and is genuinely important. But renewables are intermittent. The sun doesn't always shine. The wind doesn't always blow. And data centers cannot be intermittent. They need consistent, reliable, around-the-clock power. That is why nuclear, despite its complicated history, is getting a second look from people who are not ideological about energy. People who are simply trying to solve a math problem. The math is, we need more power, reliably, cleanly, and now. The answer to that math is not settled, but the urgency of finding one is. There is a question underneath all of this that doesn't get asked enough. We spend a great deal of time thinking about what AI will be able to do, the jobs it might change, the art it might create, the medicine it might accelerate, the dangers it might introduce. We spend much less time thinking about what AI will require. And what it requires, at the most fundamental level, is not brilliant engineers or visionary founders, or even the right regulatory framework. It requires electricity. Something invented in the 19th century. Something so basic that most of us interact with it dozens of times a day without a single thought. The thing that powers your phone, your refrigerator, your lights. The most sophisticated technology humanity has ever built depends completely on the most basic infrastructure we have ever created. There is something almost poetic about that, and something clarifying, because it means the future of artificial intelligence will not be decided only in the research labs of San Francisco, or the policy chambers of Washington, or Beijing. It will be decided, in part, by engineers extending power lines, by communities deciding what to allow in their backyards, by nations choosing whether to build or buy their energy independence, by physicists and electricians and grid operators whose names will never appear in a technology headline. We tend to think of intelligence as something weightless, something that floats, something that arrives. But the kind of intelligence we are building needs to be plugged in. And the race to find the outlet, to secure the power, to build the grid, to keep the lights on at a scale we have never attempted, may turn out to be as consequential as the intelligence itself. The future has always been written by those who controlled the critical resources of their age. We are watching, in real time, a new resource become critical. The only question is whether we're paying attention. If you enjoy documentaries that pull back the curtain on the forces quietly shaping tomorrow, consider subscribing to Chronicles of Next. Because the future isn't just arriving, it's being written, one story at a time.